So this is a spelling correction project we are doing for MeTA as an extension. So these are the team members, as you can see. So here's the problem definition. So spelling mistakes occurs when a user has a target sentence in mind, but when the user types it out as a query sentence, he or she made some sort of mistakes. And our task is to produce a suggestion that maximize the proximity between that maximize its proximity to the target sentence. So common spelling mistakes normally arises from typographic reasons or cognitive reasons. So typographic mistakes refers to the situations in which the user does know how to spell the word correctly, but made some mistakes normally regarding with the keyboard. On the other hand, the cognitive mistakes arises because the user does not actually know how to spell the word. So he or she only made a random guess based on the pronunciation. So we are aiming to correct those correct or give suggestions for common spelling mistakes. Ideally, to be able to perform suggestions and corrections on common sentences. So the three major algorithms we are using here are leverage distance, bigram, unigram language model, and double metaphone phonetic algorithm. So lavish distance. The intuition behind lavish distance is that we are not supposed to make a lot of changes from the query sentence, the query word, in order to get or restore the targeted word or sentence. Lavishly distance measures the minimum edited distance between two strings, or in this case, words. So, as this example shows, it includes such things like replacement, insertion, delete, transpose, like these. Uh, Bigram language model, we are bigram estimates the relative likelihood of different phrases based on our given corpus. So given a query, given the query, we can make inferences about the probabilities of some words that might occur within the sentence. So, which helps us to make more accurate predictions about what are supposed to be in the suggestions. Finally, the double metaphone algorithm. The intuition behind this is that the query word are supposed to be similar to the target words in terms of its pronunciation. Well, double metaphone algorithm generates encoding for words, and we could utilize this encoding to retrieve the similar homophones of the query words and perform corrections and suggestions.
As for the evaluation, overall we have achieved relatively good result in accuracy for the single word correction using common spelling mistakes from Wikipedia as a training data set. There are 5,758 words in total in the data set. As you can tell from the picture, we were able to achieve approximately 80% accuracy for our top one suggestion, and 85% for the top two, and 89% for the top three suggestions. For sentence and document correction, because of the lack of proper data set, we were not able to perform a lot of quantitative testing for the accuracy. Also, it would be hard to judge whether we do the correction correctly with the whole sentence. But we still manage to perform some testing on sentence correction. For example, for a common misspelling sentence, our spelling correction tool is able to give a decent correction to the query sentence. And I'm gonna show you with our command line. So this is basically our shell, and you take a input for the like a wrong sentence. So for example, this is one of the wrongly typed sentence with, and as you can tell, we were able to insert the spaces before the for this is an apple tree, and we were able to spot that there should be an N instead of an B before the apple tree, and yeah, but there are still a lot of fail cases where the spelling correction could fail. As you can tell from the picture, we were not able to perform the correction for when there exists a consecutive spelling mistakes. For example, for the chocolate milk, both of the words are spelled wrong, and we were only able to correct the first chocolate, but we failed to correct the milk. And in general, as a conclusion, with a limited source of dataset, we still obtain a fairly high correction accuracy. We were able to perform suggestion for some simple sentence and phrases and documents. However, some of the features of our tool is still improvable, and there are still multiple different methods we can add into our tool so that the accuracy of the correction could be improved, and the ability of correcting more complicated sentences and document could be achieved. So in the future, I think if we can optimize our performance of this spelling correction program to reach a relatively high correctness with the sentence and documents, we can also apply this tool to many other applications to work as a supporting tool. For example, we can use it to correct the text file generated by the scanner, which might contain many retrieval spelling mistakes. And that's basically it. Thank you for listening, and thank you for all the help during the semester.